Good morning, guys. Today we're going to go over 6.1, which is the beginning of a somewhat, well, today's class is easy, but tomorrow's class, when we look at logarithms, it's a little bit confusing. We will have to practice that a bit because it's something that's kind of difficult to see. But today's class is pretty straightforward. We're going to look at three things today. I'm going to just tell you what E is, or natural base. You do not have to know this part. I'm just going to explain where E comes from, what it is more or less. But you do have to know this bottom part. The bottom part is exponential growth and decay with a natural base, also called, give me a second, I always forget the number, natural base exponential functions. That was difficult. Natural base exponential functions. And you also have to know this, which is similar to what we saw yesterday, compound growth, only this is called continuous growth. But it's pretty straightforward and easy. So, actually today's class is very easy. Just a lot of theory, a little bit of problems. That's it. So first of all, what is E? Thank you. E is pretty much called the natural base. Now, again, we use many letters to represent variables. But when we see the E, that's not a variable, so that value does not change. E, it's its own number, much like pi. Pi is, even though we can also use symbols to represent variables, pi is not a variable. It's 3.14, blah, 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 blah. E itself, it's its own number, 2.718, blah, 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 blah. Profe, do I have to actually memorize E? No, it's in your calculator. You look at the calculator, one of the numbers in the bottom, you'll see E, just hit it, and you're done. You don't have to memorize E. I'll never ask you to use E with arithmetic problems. I mean, you might have to solve and isolate and, simplify, but you'll never have to memorize that E equals 10.718. So where does this number come from? Again, similar class to end behavior. Oops, where's the marker? Everything's falling down. Well, let me just use this one. I'll find the other one later. The name of the person who discovered this, or who actually worked this out, is on page 304. I usually don't require people to memorize names. It's actually, this number comes from this expression. 1 plus 1 over x, all this elevated to the power x, as x approaches positive infinity. So think of the biggest number possible, plug it in here, and that's going to give you more or less this number. And the bigger number you plug in, the closer you will be to the actual value of E. But remember, x is approaching positive infinity. You never actually reach it, so that number is also infinite. It just continues forever. You can, but again, the bigger value you use, the closer you will be to the actual true value of E, natural base. So that takes care of where E comes from. Now let's go over natural base exponential growth and exponential decay. Yesterday, we saw just normal exponential growth and exponential decay like this, right? A had to be positive, B had to be either greater than or less than 1, and that was pretty much it. Now, when you put A into the equation, it's also pretty straightforward. Your A always has to be positive. If your A is negative, for example, in this case, I don't know, does not qualify. That would be something else. It's not either exponential growth nor exponential decay. I repeat, when we have a natural base, your A has to be positive in order to qualify for natural base exponential function. If it's negative, something else. So if your A is positive, you look at your exponent. Or not your exponent, your R more specifically. If your R is positive, you're going to have exponential growth. If your R is negative, you're going to have exponential decay. And that's pretty much it. So for example, in this case, that would be decay. Again, I confirm my A is positive. Then you look at your R. If it's negative, it's decay. If it's positive, it's growth. Doesn't matter if the number is a decimal, greater than, less than. No, just positive or negative. If it's a positive number, for example, let's look at this one, 0.0000e elevated to the 0.0001x. Positive, exponential growth. Now, this is going to grow incredibly slow, but it will turn out to be exponential growth at the end. And that's one of the things. So that takes care of this. A has to be positive, positive R, exponential growth, negative R, exponential decay. Now, the last theoretical subject we're going to look at today is called continuous growth. Remember, I said yesterday, whenever you see the word compounded, when they're talking about growth, you know it's compound interest. Whenever you see the word continuous growth. And you use this formula, and it's similar to yesterday's. A is the amount you end with after the interest rates are applied. P is the principal, which is what you begin with. E is the natural base. It's in your calculator. You just plug in E. And R and T are just like yesterday. The rate of growth expressed in decimal form, that's an exponent, and how many years. Now, just give me a second. How would I work this? Pretty simple. You multiply this times this first in your calculator. Hit enter. That's going to give you a value. You write that value down. Then you're going to hit the number E in your calculator, and you're going to raise it to the value you found previously. So this value will go up here. You hit enter. That's going to give you another value, and that value is multiplied by your principal, and that will give you the final amount. Again, remember, PEMDAS, exponents. Well, okay, exponents, but you have to multiply these two first, so then you can exponentiate your E, and that answer then gets multiplied by P. Remember the case of the instant billionaires. Profe, I got a number so big, I'm getting scientific notation after I invested my money for 2 years in this bank. Does it make sense? No. Remember, do not multiply this first. You have to multiply the exponents, then raise your E to the product of these two exponents. That answer gets multiplied by your principal in that order. That's going to give you the result. So again, keyword here, continuous. You're going to see that in problem 41. You're going to have to compare a compound growth and the continuous growth and just answer the questions and which one is more beneficial or harmful for you. So that's it for today's class. Again, the theoretical concept of the natural base. E, that's in your calculator. Just plug it in. No need to memorize it. You don't have to know that, we're not ever going to use this. I was just using that to explain where this value comes from. All you have to know is that E is a constant. Values in your calculator. You can use it. Remember the natural base exponential growth or decay. You have to know when it's growth or decay. That's also part of the homework. And continuous growth. That's it for today's class. Now for the homework, on page 306, you're going to do problems 3 to 6. Now in 3 to 6, we're using natural base with exponents. So now you're going to be mixing the natural base and the rules of powers, exponents, radicals, division, etc., etc. Now for these problems, even though E is not a variable, you can treat it like, just like normal rules apply that you already know. If you're multiplying these two terms, I have the same base. Since it's a multiplication, you add the exponent. The exact same rules apply, only instead of an X, you're just changing it for an E. Same deal. That's 3 to 6. In 15 through 20, all you have to do is recognize if you're looking at exponential growth or exponential decay, and just write growth or decay. There is no need to graph. I repeat, there is no need to graph. If you ask me in Teams, Profe, do we need to graph? that just tells me you haven't seen the video, and I will take points off. So don't tell your friends. I'm just wondering to see who's gonna ask me, and just we can all have fun. So 15 through 20, no graphing. If you ask me via Teams, I'll just have fun and make fun of you. And the last one, which is actually the most important problem. It's a word problem, but it's a very simple word problem that's asking you to compare a compound and a continuous growth rate and see which one's better for you. That's the most important one because that's the one that has an actual, very, very, very useful real life application. Everybody uses credit cards. Everybody uses banks. Not everybody. Many people take loans or do investments. Number 41 will give you, at least mathematically, the best result. Real life is different, but at least, that gives you the best mathematical approach to the situation. And that's it for today's class. Make sure you upload the homework before 10 p.m. Otherwise, have a great day. I'll see you tomorrow. Tomorrow's class, we're going to look at logarithms. Students have a hard time working with logarithms because it's something that's not very visually, it's not like a square, a triangle, it's not geometry, it's not like a very nice parent function like a parabola or a linear equation or a cubic or a quadratic. It's something else. And students have a hard time working with logs, so we're going to try to practice a lot and take it somewhat slow because we're not seeing ourselves presencialmente. Now, a student asked me about tests yesterday. Again, I repeat, we're going to have a math department meeting today to see, what's going to happen, more or less. See if they can. If I'm going to ask, hey, what are the chances we reopen the school and start going, seeing the students, etc., etc. Because I'm trying my best to not give take-home tests. Because I repeat, and I've said it again, if we do take-home tests, they will unfortunately be very long, very difficult, and strictly timed, just to make the sharing of information more difficult. Even though sharing is awesome, sharing information during tests is not awesome. So in order for me to limit the amount of information sharing, I have to do multiple tests. I'm thinking about doing 10 different tests. So maybe 2 people have the same test. So you're gonna waste so much time trying to find out who has your test that you're not gonna be able to finish. So that means I have to do 10 different tests, very difficult tests and very strictly timed tests, just to make the sharing of information more difficult. So that's why I'm trying to not give tests if possible, because I don't think that's the best way to evaluate students. I like to give fair tests and sort of relaxed, not very strict as far as timing goes, to give you guys a little extra time. But if we do have take-home tests, you need to prepare for hard tests. That's why I'm telling you guys, never miss a single homework. Because if you tell me, Profe, we're not going to reopen the school within the next month, that means we will have take-home tests, and the difficulty of those tests will be offset by the weight of all the homeworks. I've said it multiple times. And even though I'm not providing daily feedbacks on who is or isn't doing their homework, I have it all saved. That's the whole point of Teams. So I'm going to go back every day when I'm going to grade the homeworks and see who did every single homework or not. And if you're missing homeworks, you're losing a lot of grades. Repito, if you're not doing your homeworks, you're missing a ton of grades. There might not be quizzes. There might not be a project. All we might have this quarter is homework and take-home tests. And believe me, you don't want to see the take-home test, if possible. I'll try to be as fair as possible, as always, pero that's the reality of the situation. If we do have take-home tests, they will be difficult. Do not miss a single homework. Besides that, have a great day. See you guys tomorrow.